In this video, we're just going to look at some derivative graphs and some of the things we can tell about a function based on its derivative graph. So this is a graph of f prime. So where is a function increasing? I'm going to start by writing down the justifications, and then we'll write down the intervals. A function is increasing when its slope is positive. Therefore, that means its derivative is positive. So let me justify that. F prime is greater than 0. Okay. Where does a function have a local minimum? Well, a minimum occurs when the function changes from decreasing to increasing. So the derivative changes from negative to positive. F prime changes from negative to positive. And I'll go back again and I'll add in the actual points. Where does f have inflection points? Well, a function has inflection points when it changes concavity. Its second derivative changes signs. Its first derivative changes direction. F prime changes direction. This is usually the justification I use. I know that people like to say it's a minimum or maximum. I just think it's easiest to kind of put one blanket statement out there that covers everything. Where is the function concave up? Well, a function is concave up when it opens up, or its second derivative is positive, or its first derivative is increasing. And then we'll sketch the graph at the end. So let's go back. A function's increasing when its derivative is positive. That looks to me to be from about negative 2.5 to 0, and from 2 to 4. Okay. A local minimum is when the derivative changes from negative to positive. That looks like that happens at negative 2.5 and positive 2. I'm going to have trouble fitting that in here. Let me kind of make a circle here. I'll go down. It's at x equals negative 2.5 and x equals 2. Inflection points occur when the derivative changes direction. So again, I might have a little trouble. Maybe let me do this in green. I'll write it right down here. A directional change to me looks like it occurs at about x equals negative 1, x equals 1, and x equals 3. It could be a little bit different than negative 1, but it looks like it's about negative 1 right here. But it's directional changes. We're concave up when the derivative is increasing. So that looks like from about negative 3 to negative 1, and from 1 to 3. Like that. A possible graph. Well, let's start with, I'm going to start with drawing f double prime. I'm going to do it in red. Okay. How I always graph a derivative is I start by marking in the spots where the slope is 0. Okay, so notice slope is 0 here, here, and here. Okay? Now, between these spots, that's how I start it to look. I say, well, geez, the f prime here is decreasing, so its derivative must be negative. Here, the derivative is, or the function is, I guess it is the derivative, is increasing, so its derivative must be positive. And here we have increasing, so the derivative must be positive. And here we're decreasing, so the derivative must be negative. And I could certainly smooth that out. I didn't do a real good, well, I'm not doing a real good job of tracing over it either, but there it is. Maybe I could do that to clean it up. That's not a bad line. Okay, so now we're to drawing the function. This is sometimes a little harder, but it really shouldn't be. We're going to draw something. It really doesn't matter where it starts. I'm just going to start up here so I feel like I have enough room. You'll notice the derivative is negative, so that means my original function is decreasing. And we said it had a minimum at negative 2.5, so it's going to now start to come back up. And it's going to increase all the way to x equals 0. Going to have a maximum. It's going to decrease to 2 and then increase until 4. And just something like that. And you can check the concavity, but that is not a bad picture. Just using, where is it increasing and decreasing, something like that. Okay? This is just playing with a derivative graph. This I took from a college board kind of prep guide. It says h of x is equal to f multiplied by g, where the functions f and g are given. Find h of negative 2 and h of 3. Well, h of negative 2, of course, is equal to f of negative 2 multiplied by g of negative 2. Let me do that here. So f of negative 2 multiplied by g of negative 2. So we go down to the graph and look. F of negative 2 looks like about 1. And g of negative 2 looks about like 2. So maybe 1 times 2 is 2. And h of 3, of course, would be f of 3 multiplied by g of 3. So we go down and look. F of 3 looks like about, I don't know, maybe about 1.5. G of 3 looks like about negative 2. So negative 2 multiplied by 1.5 is negative 3. Okay. Now, estimating f prime of negative 2. So now we got to estimate the slope. Okay. So f prime, you kind of look at this and you say, well, we could pick a point on either side, or we could kind of just take a guess. Maybe just saying that it's negative, it's about negative 1 or something. Here at 3, it looks again, it's negative, so we could say, well, it looks like it's about, and I'm just kind of estimating. You could certainly do a better job with picking points on either side. G prime of negative 2, that looks like positive. It doesn't look like, 1, maybe like positive 0.5. G prime of 3, right in here, and that to me looks like 0. Okay, so estimating the slope. So now when it says estimate h prime of negative 2, now we've got to use some product rule. So remember, h was f of x multiplied by g of x. So h prime would be first times derivative of the second plus second multiplied by derivative of the first. Like that. Okay. So now it was h prime of negative 2, so we know what f of negative 2 is. We'd already figured out that that was 1. We figured out that g prime of negative 2 is negative 0.5. See, we did all this above, so it goes pretty quick. G of negative 2 we said was 2, and f prime of negative 2 we said was 1. So we end up with it's positive 0.5, excuse me. Positive 0.5, just delete that, plus 2, so we get about 2.5. Now, I'm running out of room here. I'm going to rely on the fact that you could plug 3 in and handle that, f of 3 multiplied by g prime of 3. Again, we created all of those up in A and B. Now, h of x is equal now to f of g of x. Well, h of negative 2 then would be f of g of negative 2. Well, what's g of negative 2? Let's just focus on that. We'd already said down here that h of negative 2 was about 2. So this is really just saying, well, what's f of 2? Well, f of 2 looked like about 2 or maybe just a little less. I think we actually said it was like 1.5. But that's how we do that. Now, the next thing is it asks, for the derivative. And this is really chain rule, right? if h is equal to f of g of x, then h prime is equal to derivative of the outside, leave the inside alone, multiplied by the derivative of the inside. Okay, we got to use some chain rules. So it says is h prime of negative 3 positive or negative? Well, let's figure out f prime of g of negative 3 multiplied by g prime of negative 3. Okay, so g of negative 3 to me looks like about 1. So let's replace. We got f prime of 1 multiplied by g prime of negative 3. Well, now remember, this is asking for slope. So for me, I look and I say, well, f prime of 1, this is a positive slope right here. Just going to put a little positive. G prime of negative 3, that's a positive slope. Positive multiplied by positive is positive. Now we can do the same thing. The next part C says, okay, do this same thing for negative 1. Let me write that down here. We got f prime of g of negative 1 multiplied by g prime of negative 1. Remember, it's just the chain rule. Okay. So g of negative 1 looks like about 2. So we got f prime of 2 multiplied by g prime of negative 1. Well, f prime of 2, this is saying what's the slope at 2. To me, it looks like about 0. G prime of negative 1 also looks like 0. If you didn't think one looked like 0, it looks like the other one is. So I would say that this one is 0. So this is just a nice little review using a graph of f and g of how we could do a lot of different things using the derivative rules. The one thing to be careful of is what graph you've been given. And remember that, since this is f, if we're looking for f prime, we've got to find the slope of f. And I just kind of, estimated it, and it worked pretty well, I think.